Now that we have consolidated the types of families / functional groups, we definitely want to focus on, if you are given a molecule, can you identify them? Okay. So yes, there's a bunch to choose from. So you want to make sure you can just basically identify parts of that group that make it distinguishable from the others. So when we're looking at this molecule here, I'm already starting to see a couple of things. One, I'm seeing that we have oxygen here, OH group here, OH group. That means that these are going to be alcohol. So there's alcohol here, and alcohol here. How can I verify that? We can say this entire thing is in our group in alcohol. We can say this entire thing's in our group, or we can also say this entire thing's in our group. We also see a benzene ring here, or you can also say aromatic compound. We see alternating double and single bonds, and of course they do have the ability to have resonance. And then we definitely see our NH groups here, which would definitely be our amine groups. Okay. So sometimes, especially when it comes to this introductory portion, we really are going to be about identifying these families. So can you identify that this is an ester, aldehyde? Can you identify a ketone or alcohol? Now some folks might say, what about these methyl groups or the alkyl group? You definitely don't have to identify the alkyl groups, but you definitely want to be able to use them for naming, right? But it's not going to be a part of one of the functional groups you have to specifically identify. And also, we have to be okay being able to see skeletal structures, of course, our condensed structures, or Lewis, or a mixture of all of them. You gotta just make sure that we're comfortable with that. So if you want to go back to the first part of this overall lecture, then that will help you there. Now, we briefly spoke about organic reactions, like very brief, right? I just listed what they are. But I want to make sure we took the time to focus on one type of reaction that you will be tested on. So this is one of those flashcard moments, okay? And those are going to be our redox reactions. So just like in organic chemistry, we have oxidation and reduction, which equals redox reactions. But our understanding in organic chemistry is a little bit different because it's only based on what is attached to that carbon. Okay, so whatever is attached to that carbon is what is going to let us know whether or not we have oxidation or reduction. So how do we figure this out? Well, if this carbon gains an oxygen and loses a hydrogen bond, then it's going to be oxidized. So let's talk about that. Here we have an alkane. As you can see, this is just a plain old ethane. If it was to gain an oxygen, that means this carbon here, which we know is going to be carbon attached to this hydrogen, attached to this hydrogen here, attached to this. So if this hydrogen here is lost and it's replaced with an oxygen, you now have COH, H, H, and then of course still attached to that carbon. So what happens is when you gain an oxygen in a bond and you lose a hydrogen, you're going to be dealing with oxidation. And so your goal is, hey, if I've given a molecule or an organic compound here, can I basically tell whether or not it's going to be oxidized or reduced? And you would have to make sure that you're identifying certain areas to help you make those choices. So if you're asking for oxidation, of course, you will see something like an alkane and then, or an alcohol continuing on until you get like a carbonyl group, like aldehydes and carboxylic acid. But if you're talking about going the opposite direction, which is going to be reduction, then you're talking about the carbon hydrogen bond is going to be gained and an oxygen is going to be lost. So let's see this one here. We have carbon, double bond to oxygen. We have a carboxylic acid group, okay? And we also have it attached to CH3. So when we actually lose an oxygen and gain hydrogen there, so now we have carbon double bond to oxygen, we have a hydrogen here, okay? And then we still have our CH3 group. We now effectively create a brand new structure, which is now an aldehyde. So it's almost like going from carboxylic acid to aldehyde. If you lose an oxygen and gain a hydrogen, you are effectively doing reduction. So let's go ahead and have an example of it. So again, we first want to kind of recognize what is really going on. When you're seeing double bonds, the only thing that really can happen is that they be reduced. When you're seeing things like alkanes, for example, or anything that has the ability to gain an oxygen, then they have the ability to be oxidized. So when I'm looking at both of these examples, I see that I have a carbonyl group here and a carbonyl group. And so some questions might just ask you, okay, go ahead and figure out the product of the reduction. So they're telling you general reduction. But also just by seeing that we have double bonds, in my head, I'm thinking reduction as well. So that means I'm focused on the carbon that is connected to the oxygen group, okay? Because it's the only thing that has the ability to, again, lose oxygen and gain hydrogen. So we must lose oxygen and gain hydrogen in order to have the correct structures. So let's see. If we were to have reduction happen in both of these areas, We're only focused on this carbon, and I'm going to have my CH3 here attached to carbon, which is going to have an OH here, okay? And then it's going to be attached to another hydrogen here, and then CH2, CH3. So this would be what that looked like. As you can see here, I've lost an oxygen bond, and I have to gain a hydrogen. Let's continue. This one here, same thing. I'm going to have reduction here. That means I'm going to have CH3, CH2 staying the same. I'll only focus on the one that can actually be changed. Then I have carbon, OH, and attached to another H group as well. Okay? Okay? We also have the same hydrogen that we have here, and then we also have gain a hydrogen. So that would be how you would basically approach these questions. Find out if you see double bonds for reduction, see if you see alkanes or anything for oxidation. Mainly we'll be focused on reduction, just to let you know, and then you'll be able to see examples like you see here. Okay? That concludes our organic chemistry conversation, folks. And look how far we have come getting an understanding of all these different families. So this lecture serves only as the conversation started when it comes to open. Just to start. Okay, you will learn the ways in which nomenclature rules will change. When you get to actual organic chemistry, you learn all the smaller details. So there's so much more that can be explored and added. Like, for example, we didn't go over synthesis reactions. We didn't talk about the creation of new compounds. Like drugs, materials, ligands, fibers, it all comes from synthesis reactions in organic chemistry. We didn't really dive as deep as we could have into industrial uses of these compounds. Okay, but we have our start, and that's where I want you to focus on. Focus on the uses. Focus on how to name them. Focus on examples. Get your flashcards ready, okay? And as a bonus, click the next video to see some of the organic mafia in action. Stay at the club, y'all.